All right, so here is a video of your semester 1 review. We'll see how far we can get on this. Number 1, solve the inequality, then graph our solution. So we have the absolute value. The absolute value of 2x minus 3 is less than or equal to 5. So less than is an and statement. Anything less than 5, so we have to be between or equal to 5 and negative 5. So all these numbers are less than 5 away from 0. So that's why this is the and statement. So we get that negative 5 is less than or equal to 2x minus 3, which is less than or equal to 5. And then whatever we do to the middle, we're going to do to both the right and the left. So then we have negative 2 is less than or equal to 2x. The negative 3 and 3 cancel, less than or equal to 8. Divide by 2. And negative 1 is less than or equal to x, less than or equal to 4. And on the number line, negative 1 and 4, closed circles, because it's less than or equal to, and it's greater than 1 and less than 4, and that's the numbers between negative 1 and 4. Number 2 says solve the equation absolute value of 2x plus 3 equals 3x and check for extraneous solutions. So extraneous solution happens when we get a negative and the absolute value equal to a negative, so we'll check that in the end. So we have to write two equations because 2x plus 3 could equal positive 3x, and 2x plus 3 could equal negative 3x. Let me fix that. Okay, that's the highlighter. And so we'll solve these minus the 2x. So 3 equals x. That's one answer. I'm going to subtract the 2x minus 2x. We get 3 equals negative 5x. This should be a minus. And then we divide by negative 5. And x equals negative 5/3 and 3. So when we come back, we look at the problem. If we take negative 5/3, and if we plug that in here, we get the absolute value of 2 times negative 5/3 plus 3 equals 3 times negative 5/3. That means the absolute value is always going to come out positive, and it can't equal this negative here. So the negative 5/3 is extraneous. And then we'll check the 3. 2 times 3 plus 3 is the absolute value of that equals to 3 times 3. That's 6 plus 3, absolute value of 9 equal to 9. Yes, that works. So our answer is 3 and 3 only. So looking at number 3, I'm going to move some of this out of the way. Number 3, the absolute value of negative 2x plus 3 is greater than 7. So greater than 7 means I want numbers more than 7 away from 0. So we're looking at numbers greater than 7 or numbers less than negative 7. So I have to write two equations. Negative 2x plus 3 is greater than 7, or negative 2x plus 3 is less than negative 7. And subtract 3. Negative 2x is greater than 4. Divide by negative 2. Remember, when we divide by a negative, our sign, our inequality sign, has to flip. So we get x is less than negative 2. Or, subtract the 3. Negative 2x is less than negative 10. Divide by negative 2. And x is greater than, because that sign has to flip, 5. So on a number line, this is 5, open circle, shaded greater than 5, or negative 2, open circle, less than negative 2. And in set notation, we would have curly braces around that, like this. Okay, and now we're looking at number 4. Solve the system of linear equations. Y equals negative 3/4 x plus 1/4, and y equals 3/4 x minus 3/4. So they're both equal to y, so I'm going to use the substitution method, set them equal to each other. 3/4 x minus 3/4, oops, I don't know what that was, equals negative 3/4 x plus 1/4. And then I'm going to add 3/4 x. And when I add 3/4 x plus 3/4 x, we get 6/4, which is 3/2. And then I'm going to add 3/4. So I get 3/2 x equals 1, because 1/4 plus 3/4 is equal to 1. Then I can multiply by my reciprocal 2/3. So x equals 2/3. And now another way to do that would be to multiply both equations by 4, and then you could eliminate the fraction. You'll end up with the same answer. So y equals 3/4 times 2/3, that's my x, minus 3/4. So this is 3 goes into 4 2 times, and 3 cancels the 3, so I have 1/2 minus 3/4. And 1/2 minus 3/4 is negative 1/4. So my ordered pair is 2/3, comma negative 1/4. That's my final answer. In the end, you're going to have the two fractional answers. Okay, so we have a group of 68 people attend a ball game. There were 3 times as many children as adults in the group. So the number of children equals 3 times the adults, right? 3 times as many children means if there's 5 adults, then 5 adults times 3 would be your 15. So you're multiplying the number of adults by 3 to get the number of children. And then the number of children plus the number of adults is equal to 68 people. Write a system of equations that you could use to set up this problem where A is the number of adults and C is the number of children. We've already done that, solved the system. So I'm going to use substitution. This is already solved for C. So 3A is equal to C plus A equals 68. So 4A equals 68. Divide by 4, and A equals, so A equals 17, and then the number of children is equal to 3 times 17, which is 51. So there were 51 children and 17 adults. Number 6. Write and graph a system of inequalities in which x and y are each less than 3. So x is less than 3, y is less than 3, but not less than negative 2. So that means they're greater than negative 2. So x has to be between, x and y have to be between negative 2 and negative 3, and positive 3. And this would be, let's see, on a coordinate plane, negative 2, dashed lines, 1, 2, 3, dashed lines, and then 1, 2, 3, and 1, 2, 3, or negative 2. So between would be the numbers in this box. And you could also write x is greater than 2, greater than or equal to, so maybe these should be solid. Y greater than or equal to negative 2. So you can write it as the between statement, or you could write it as the single statement. Number 7, factor 16x squared minus 25. We should recognize this as a difference of squares because we have a perfect square minus a perfect square. So this is 4x plus 5 times 4x minus 5. Number 8, write the expression is as a complex number in standard form. We have 5 minus 2i plus 3 minus 2i. Combine your real, 5 plus 3 is 8. Combine your imaginary, negative 2 plus negative 2 is negative 4i. And that's your final answer. And lastly, graph the absolute value equation. Y equals negative absolute value of 2x plus 3. This one, we're going to find our vertex. And because I have a coefficient on the x, I've got a horizontal shrink factor of 1/2. So I'm going to have to just take 2x plus 3, set it equal to 0 to find the x value of the vertex. There is no k over here, so it's going to be at 0. So minus 3, 2x equals negative 3, and x is negative 3/2. So my vertex is negative 3/2, comma 0. And I know that it opens down. So let me make some space. We're going to draw this. 1, 2, so negative 3/2, comma 0 would be here. And it opens down, so let's pick a point. Let's pick 0. Negative 2 times 0 plus 3. It's be negative absolute value of 3, which is negative 3. So that's the point 0, comma negative 3. 1, 2, 3. And then I'll use 1.5 on the other direction. I'll use some symmetry to graph that. So not straight. And that's your absolute value function. That's number 19. I don't know how 19 got all the way at the bottom there, but we'll do that one anyways. Okay. All right, number 9. Find this product, I times 2 plus I. Distribute, so I get 2i plus I squared. I squared equals negative 1, so 2i minus 1. In standard form, it's the negative 1 first, the real number, plus the imaginary, so negative 1 plus 2i. Number 10, 2x squared plus x plus 3 equals 0. I'm quickly going to see if I can factor this. I know I'm not going to want to do completing the square. Algebra is not an option because I have the b term. So let's see real quick, can I find factors 2x and x? If I put 3 here and 1 here, remember all of these are positives. They both have to be positive. That gives me 2x and 3x, and that's not going to work because I need it to be 1x. So one of them would have to be negative, and that's not going to work. So factoring is not an option here, and so that leaves me with quadratic formula because I would have to complete the square with some fractions, and that's not usually what we want to do. So negative 1, b is 1, right? Plus or minus the square root of b squared, 1 squared, minus 4 times 2 times 3, 4ac, all divided by 2 times a, which is 2. So I get negative 1 plus or minus the square root of 1 minus 4 times 2 is 8 times 3 is 24 over 4. Negative 1 plus or minus the square root of negative 23 over 4, which is negative 1 plus or minus I square root 23 over 4, and that's my final answer. We're going to have to do the same thing for number 11. 2x squared minus x plus 2, so negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 2 over 2 times 2, so that's 1 plus or minus the square root of 1 minus 4 times 2 is 8 times 2 is 16 over 4, 1 plus or minus I square root 15 over 4, because this is going to be negative 15, and that would be I square root 15. And then number 12, negative 5x squared minus 3x equals 4. I like my x squared positive, so I'm going to add 5x squared, and I'm going to add 3x, so I get 0 equals 5x squared plus 3x plus 4. And I don't think this is factorable because in order to get 3, I would need to subtract. So I'm going to go straight to quadratic formula. Once again, negative 3 plus or minus the square root of 3 squared minus 4 times 5 and over 2 times 5. So negative 3 plus or minus the square root of 9 minus 80, because 16 times 5 is 80, divided by 10, negative 3 plus or minus I square root 71 over 10. I'm just skipping the step where I write negative 71 under the radical, because when it's negative, the I has to come outside. Number 13, simplify 2I times negative 3I times 4I. 2 times 3 is 6, times negative 3 is negative 6, times 4 is negative 24, I cubed. Negative 24, I cubed equals negative I, and that's negative I times negative 24, so that's positive 24I. Number 14, I to the 7th power. We divide 7 by 4. We get 1 remainder 3. Remainder 3 means it's equivalent to I cubed, which is negative I. Okay, so number 15, evaluate the polynomial function when y equals 5. I'm going to use synthetic substitution. Y equals 5. I'm going to write down my coefficients, 8, negative 2, negative 3, and negative 5. Because my exponents go 3, 2, 1, 0, I don't need to fill in any missing terms. If it didn't have this y term here, say this wasn't there, then I would put a 0 in for it. And then the number I'm plugging in is 5. When it's synthetic substitution, I do the exact number. I don't change the sign on anything. And then let's say we bring down the 8. We multiply the 8 times the 5. So we get 40. We add negative 2 plus 40. Gives us 38. And then we do 38 times 5, which I'm going to need a calculator for. 190. And 190 minus 3, 187. And 187 times 5 gives me 935. So 930, that's my answer when it's synthetic substitution. And if I were to plug 5 in for each of these terms, I would get the same answer. Number 16, find the product. We're just going to multiply. There's several ways to multiply. You can distribute the 4x to each term, then distribute the negative 1. I like my vertical multiplication, 3x squared minus 2x minus 4 times 4x minus 1. And we multiply just like we did in elementary school. We were multiplying two big numbers, negative 1 times negative 4, negative 1 times negative 2x, and negative 1 times 3x squared, and then repeat with the 4x. So I get positive 4. I get positive 2x, negative 1 times negative 2x, and negative 1 times 3x squared is negative 3x squared. And then we leave a blank, right? Or we put a 0 in there because we don't have any constant terms. So 4x times negative 4 is negative 16x. And 4x times negative 2x is negative 8x squared. And 4x times 3x squared is 12x cubed. And then because I left that blank or put that 0 in, all of my like terms add up. I get 4. We get negative 14x, we get negative 11x squared, and 12x cubed. And we could have done that using the generic rectangle. You could have just distributed. There's lots of ways to do this problem. And number 17, divide using polynomial long division. So when we do this, 17, we are going to do m plus 2 divided by m cubed plus 8. And I'm going to do this without adding in the zeros, which is an option. So the first thing I look at is, what is m cubed divided by m? So m cubed divided by m is m squared. And then m squared times m is m cubed. And m squared times 2 is 2m squared. And then it's plus right now. We need to subtract. So it becomes minus 2m. And I subtract. I don't have anything to subtract the 2m squared from, so I have negative 2m squared plus 8. Bringing it down. And then negative 2m squared divided by m is negative 2m. And negative 2m times m is negative 2m squared. Negative 2m times positive 2 gives me negative 4m. And then I'm going to subtract, so those become plus. And I end up with 4m plus 8. And then 4m divided by m is 4. So plus 4. And 4m plus 8. And then we're going to subtract, and we get 0. So that means m plus 2 is a factor of m cubed plus 8, and the answer is m squared minus 2m plus 4. And 18, x squared plus 2 goes into 5x to the 4th minus 3x squared plus 4. So we have, first remember, 5x to the 4th divided by x squared gives us 5x squared, and then 5x squared times x squared is 5x to the 4th, and 5x squared, 5x squared times 2 gives us 10x squared, and it's positive, but we're going to subtract. So we get negative 13x squared plus 4, and negative 13x squared divided by x squared is negative 13. And so we get negative 13x squared minus 26. Negative 13 times 2 is negative 26. Subtract, so those become plus now. The x squareds cancel. And I get 30. This is my remainder. And I put my remainder over what I divided by. So my final answer is 5x squared minus 13 plus 30 over x squared plus 2. And you can see how on this one, I didn't ever need the space filler. So you can do that. What I recommend on a problem like this is making sure, you have to make sure you're always looking for like terms and not adding terms that are not alike.